So you just finished taking your electron and their location notes. I'm going to summarize a lot of the stuff you should have picked up from the notes and hopefully clarify it a little bit for you. There's a video following this that will help you apply these notes. So hopefully this video will give you a better idea of what you're reading in the notes, and the second video will make even more sense of it. So the point of the notes is that electrons within an atom have a specific location. We can't 100% predict where that exact location is, but we can, in general terms, describe that location. And we do that with quantum numbers. Quantum numbers are 4 numbers that give us an idea of the location of the electron. So the first number is the energy level. And if you remember drawing the Bohr models, you were drawing these rings, which are energy levels. So the higher away from the nucleus, the higher the energy level, and that's the first number we write. The second is a sublevel. So if you think of energy levels as floors, think of sublevels as rooms. So there's specific types of rooms, and in this case, sublevels each have a specific shape, and you saw those shapes on the PowerPoint: sphere, dumbbell, lobed, multi-lobed. Now these get letters, but each letter also has a number associated with it, and so that's the quantum number for that. The third quantum number is the magnetic quantum number, or it's looking at what orbital is the electron in. So if the principal quantum number is the floor and the sublevels is the type of room, think of orbitals as beds. So an S room could only have 1 bed, a P could have 3, a D could have a 5, and an F could have 7. Now depending upon which bed it's occupying or which orbital it's occupying, you'll get a different number. So for an S orbital, there's only one option, so you would always get a 0. But in a P, you can see that an electron could be in one of 3 orbitals. So depending upon which one it's in, it will get a different number. Okay, same thing with D's and F's. Remember, with the electron, we're trying to state as specifically as possible where the electron is. And lastly, we get to what is the electron's spin direction. So if it's spinning clockwise, we represent with an up arrow, but as a number, that's a +1/2. If it's spinning counterclockwise, we represent that with a down arrow, that's a -1/2. So those were quantum numbers. And we're going to talk about how you write out the quantum numbers, but to help us write quantum numbers, we draw something first called an orbital diagram. And an orbital diagram uses some of these numbers, and it also uses boxes or lines along with arrows to showcase the electrons. So there's 3 rules for drawing orbital diagrams. So I'm going to go over these rules, and then remember in the next video we'll apply them. So you saw this chart on your notes. And when I do the second video, I'll show you how we draw this chart. But this is Aufbau's rule. He said if you have electrons, they're going to fill orbitals with the lowest energy levels first. So remember, 1, 2, 3, 4, 5, 6, 7, those are energy levels. So an electron is going to fill the lowest energy level, the lowest numbers first, and then it's going to go to the higher numbers. And each energy level has a different number of sublevels, so there's a specific order. So what this chart does is it helps you figure out where are electrons going. So first, your electron would go into the 1s, then it would go into the 2s, then 2p, 3s, 3p, 4s, 3d, 4p, 5s. So you can see I'm reading this chart downwards, and we'll use this chart momentarily, but this is how you read the chart. Your next rule for orbital diagrams is Pauli exclusion principle, which says each of the 2 electrons in an orbital has opposite spins. Okay, so this is an example of an orbital diagram. So an orbital diagram can either use a box or a line, and underneath it is the energy level, the sublevel, and this exponent is the number of electrons. And we represent the electrons with arrows. Now there's 2 electrons in this space. what Pauli exclusion principle says is if two electrons are in the same space, they have to be shown spinning in opposite directions. The last rule is Hund's rule, and Hund's rule says every orbital of the same sublevel is filled singly, then paired. So if you remember me talking about how S's only have one bed, they only have one orbital. So electrons can only go into that spot. So if I have two electrons, they're both going to be pushed in there for any S. When you get to P's, there's 3 options. So what Hund's rule says is if you don't have every electron, so there's a possibility of 6 electrons that can sit in here, but we only have 2, that the electrons are going to spread themselves out into each orbital before they pair. So here they were put together. Okay, so we're just looking at the P, and that's not how we do it. Okay. Here you can see they're spread out. So this is the correct way. The electrons are spread out. Okay, just think of if you and a friend went to a room that had 3 beds. You're not both going to sleep in the same bed. You're going to spread yourselves out. Okay, you're going to give yourself the space. Same thing with electrons. If they don't need to be near that close to each other, are not going to be. So those are the notes, and now we're going to go on to the worksheet that you have to complete in applying these notes.